Every day, millions of trucks travel our country's highways. Their job is an essential part of the United States economy, and it is estimated that over 10 million workers are employed in trucking-related jobs. And everyday truckers must adhere to federally mandated regulations, which typically limits them to no more than 11 driving hours during a normal 24-hour period. Once that driving limit has been reached, drivers must stop their trucks and rest 10 continuous hours before once again proceeding toward their destination. The drivers park their trucks wherever space allows, in large truck stop lots and in state-operated rest areas, for example, with the overflow often necessitating parking along highways and on interstate ramps. During the time when the trucks are stopped, their main engines often continue to operate in order to provide warmth or cool the cab while the driver rests. The fuel consumption of the engine continues, and some long-haul trucks idle 2,400 hours a year or more, while consuming about 2,400 gallons of fuel during that time. In 2004, the U.S. Environmental Protection Agency's SmartWay Transport Partnership was launched. The reduction of engine idling is one of the missions of the partnership. Through the voluntary SmartWay Partnership, the EPA and its partners expect to eliminate 33 to 66 million metric tons of CO2 emissions and up to 200,000 tons of NOx emissions by 2012. This represents savings of as much as 150 million barrels of oil per year. Beginning in 2006, the Clean Transportation Program at North Carolina State University coordinated a grant from the SmartWay Transport Partnership to study and evaluate idling reduction opportunities. The university's partner in the study was Volvo Trucks North America, which has a vested interest in building and promoting the use of energy-efficient trucks of all types.
We have in our industry, over-the-road trucking, a large problem to the tune of 1 billion gallons of diesel fuel burned per year. Volvo recognizes that. We're a large part of the over-the-road truck market, and we have come up with, through this project, 2 solutions: HVAC system powered by alternating current, and for mobile purposes, a generator by which to produce that power.
Auxiliary power units, or APUs, were installed for the purposes of the study in 20 trucks that were operated by 2 different commercial carriers. Among the data gathered from these fleets was how often and how long the trucks stopped, and whether the drivers used the main engine or the auxiliary power unit during those periods.
We observed idling for 2 different fleets. For the first fleet that has single drivers, the total amount of idling per year was about 2,100 hours per truck. And of that, about 1,500 hours was attributable to rest stops where the driver was using the sleeper compartment for comfort. For the other fleet, which primarily had a pair of team drivers, the amount of idling was only about 800 hours per year, and of that, only about 250 was likely to be for rest stops.
The field test lasted approximately 18 months, with trucks traveling over 2.8 million miles throughout 42 states. Over 190,000 hours of data were gathered, covering almost 16,000 hours of main engine idling and over 17,000 hours of auxiliary power unit operation. During the field test, single drivers would use the auxiliary engine during rest periods more often than would team drivers, who would make fewer rest stops. The APU engine use by single drivers resulted in a 22% reduction in fuel use and carbon dioxide emissions, a 47% reduction in nitrogen oxide emissions, a 30% reduction in hydrocarbon emissions, and a 9% reduction in particulate matter. In order to estimate real-world emission reductions, exhaust measurements were taken from APUs similar to those used by the test fleets, and that data was correlated with the data received via the Volvo Link satellite system during the test period from the fleets. The HVAC system that was installed in the fleets was the Dometic self-contained auxiliary air conditioning system. In addition to being powered by the auxiliary power units, the Dometic HVAC units can alternatively be powered by a rechargeable auxiliary battery pack. But the most green-friendly solution of all is the availability of a 120-volt connection where the driver can pull up to an electrified area at a truck stop or where trucks stop and just plug into a power source and operate from the electric grid.
Every gallon of diesel fuel that we can save either through the use of an auxiliary power unit, which is a much smaller engine, or plugging a truck in, is going to save not only money, but it's going to save in emissions. Every gallon of fuel that's burned creates 19 pounds of carbon dioxide, and carbon dioxide is the primary emission of concern with our global climate change problem.
Fuel prices continue to soar, and the savings realized by the use of the APUs, battery packs, and future electrification installations has become an important factor in the sales of new trucks, and more Volvo tractors are leaving the production line after being fitted with the new energy-efficient HVAC systems, auxiliary power unit support engines, and the ability to plug into shore power. The selection of this equipment has been made easier by being included in Volvo's TM2 data book custom ordering process.
Many of our customers are very conversant about EPA's Smart Way and what that means, and it's coming more to the forefront that idle elimination technology solutions be available on the product. So to that end, we have a web-enabled sales tool where we provide that functionality for those customers that are interested in those attributes.
Smart Way program has worked out really well for Volvo trucks in that what we've allowed the customer to do is to select a single code, and that provides them with the correct engine, air fairings, and all of the necessary equipment in order to meet the Smart Way program specifications. Part of those specifications is the reduction in idle and reducing the carbon emissions, not just while the vehicle is operating, but while it's parked.
In addition, Volvo business units, such as Volvo Logistics, are dedicated supporters of the Smart Way mission to reduce fuel use and minimize emissions.
Volvo Logistics is very excited about the technology that's coming from Volvo Trucks North America. As Volvo Logistics North America, we require our carriers to have an environmental management program or to be Smart Way compliant. In Radford, Virginia, which is our central hub, we've actually put no idling signs up, so when the drivers come in, we're asking them not to idle when they're making the deliveries to our hub.
The conclusions of the EPA Smart Way study, as conducted by North Carolina State University in association with Volvo Trucks North America, are important. APU use was shown to be responsible not only for fuel use reduction, but also for a 22% reduction in greenhouse gases. As fuel costs spiral upwards, transport companies large and small, and independent owner-operators as well, are joining the EPA's Smart Way partnership in order to reduce fuel consumption and thereby reduce emissions. Federal and state agencies, research institutions, private carriers, independent drivers, and many others are taking steps forward to technically advance and grow the industry so that there will be a bright future for trucking and the environment in the United States.